So here we have a circle with a diameter and a radius drawn. Let's go ahead and label some points. So A, B, and C are points on the circle. O is the center of the circle. An arc is just a portion of the circle. So it's part of the curve of a circle. It's a minor arc if it's less than 180 degrees. A full circle is 360 degrees, so if it's less than half a circle, it's a minor arc. So it's less than half of a circle. We have, in our drawing here, we have two minor arcs. We have AB. Just put a little curve over it. Put an arc over it. And also CA, or AC, is a minor arc. A major arc is greater than 180 degrees. And for a major arc, you have to label it with 3 letters. For example, ABC. Arc ABC is a major arc. You can't just say AC because you would assume that it's the short way. So 2 letters is a minor arc, 3 letters tells you that it's a major arc, because it tells you which direction to go around the circle. Then there's a semicircle, which is exactly 180 degrees. It's half of a circle. CAB is the semicircle. You do use a 3rd letter for semicircles just so you can tell which portion of the circle it is, so you can know exactly which arc. So if we just said CB, you wouldn't know if it's the top of the circle or the bottom of the circle. So you do use a 3rd letter to distinguish. The measure of an arc is measured in degrees, and it's just the portion of the circle. So how many, if you split it into 360 degrees, how much of that circle would it be? And the measure is equal to what's called the central angle. So the measure of arc AB is equal to the measure of the central angle AOB. The length of an arc length, is a portion of the circumference. Circumference is how far around the whole circle. Since an arc is a portion of a circle, it just is related to how much of the circle it is. So the length of an arc, AB, is equal to the measure of the arc over 360 so it's what portion of the circle times the circumference, and circumference is pi times diameter. A sector is like a slice of a pie, and just like length, the area of the sector is the fraction. So the area of the sector that's marked here, sector formed by AB, is equal to the measure of that arc out of 360 times the formula for the area of the circle, which is pi times the radius squared. So it's just what fraction of the entire area. and for length it's what fraction of the entire circumference. So using the circle over here, find the measures of the following. AB, the arc AB is 45 degrees because it's the same as the central angle. Angle BOC is going to be 30 degrees because that's how much the arc is. The arc and the angle are the same. Arc ACD, we know that this is 30, we have 45 and 110. ACD tells us that we're going this portion, so we add 45, 30, and 110, 185. AD would be the shorter way then, so it's whatever's left over, 175 degrees. Another example, we have
We need urges, please add.
a clock has a pendulum 32 inches long. If the pendulum swings through an arc of 12 degrees, how far does the pendulum travel? So it's asking for the arc length. We know the radius. We know the measure of the arc. So it's going to be 12 over 360 times the circumference, if this was an entire circle, would be pi times diameter, or 2 times the radius times pi. The radius is 32. So by multiplying out, 12 times 2 times 32 is 768 over 360 times pi. So multiplying all the way using decimal approximation for pi, we get about 6.7. And since that's in inches, this is also inches. To find the area of the shaded sector, we know the radius, we know the measure of the arc, or in this case central angle, which tells us the measure of the arc. So it's 75 out of 360, 75 degrees out of the whole circle, 360, times the area of the whole circle, which would be pi times the radius squared. Multiply that out, that's 7,500 pi over 360. And using a decimal approximation for pi, we get 65.45 inches squared, because it was the radius was 10 inches. So now let's talk about another angle inside of a circle, and that's the inscribed angle. That's where an inscribed angle has the vertex on the circle, and it cuts or subtends the arc. So the measure of the angle is 1/2 the measure of the arc that it subtends, or the arc that it forms with its endpoints. So in this example, I'm trying to find the measure of angle BAC, which is an inscribed angle. Since the central angle is 40, the arc is 40, which means the inscribed angle is half of that. So the measure of angle BAC would be half of 40, which is 20 degrees. So some more examples. Find the value of x. So we do have x is the measure of the inscribed angle. We know we have a 170 degree arc and an 80 degree arc. We don't know how much is left for this arc over here, but we can figure it out because a full circle is 360 degrees. And here's 170 and 80 for a total of 250. So if we subtract 360 minus 250, we get 110 degrees for this arc. So x is the inscribed angle that cuts that arc, subtends that arc. So that means x is going to be half of that. So x equals 55 degrees. In our other figure, find the value of y. This time we're given the measure of the inscribed angle is 20. So that has to be half of the measure of the arc, so the arc must be 40, which means the central angle is also 40. So y equals 40. And in our last example here, we have find the measures of the following angles, where O is the center, and AC and DF are diameters. They go through the center, that makes sense. So the measure of angle COD, O is the center, so that's a central angle. So it's going to be equal to the arc, so it equals 120 degrees. Angle B, so this angle down here, we know AC is a diameter, which means that's a semicircle, a half of a circle. So the arc there is 180 degrees, which means angle B is half of that because that's an inscribed angle. And the arc that it subtends is 180, so half of 180 means our angle B is 90 degrees. So you could use a little shortcut there. If you have a triangle basically, and the hypotenuse is a diameter, or if one side of the triangle is a diameter, then it is a right triangle, and the diameter is the hypotenuse, which means we have a 90-degree angle. Angle C is an inscribed angle. The corresponding arc is 60 degrees, so take half of that for the angle, will be 30 degrees. Angle DAB, since AC is a diameter, that means it's 180 degrees total. If there's 120 from D to C, that means A to D must be 60. Also, DF is a diameter, so that means it's 180 degrees here, which means arc CF must be 60. So for the measure of angle DAB, we can look at the arc that it subtends, which is a total of 120 plus 60 plus this portion, which we're not sure about yet, but we know a full circle is 360. And so far we have 60 plus 60 plus 60 plus 120. That's 240, 300, which means there's 60 degrees left over for this arc. So angle DAB subtends an arc that is a total of 120 plus 60 plus 60 degrees, 240 degrees. Since it's an inscribed angle, it's half of 240, 120 degrees. Angle D, this angle up here, it subtends the arc, or cuts the arc from A to F, which is a total of 60 plus 60, 120 degrees. Since it's an inscribed angle, it's half of that, or 60 degrees.